All right, so we're going to go ahead and get 4-4 started. Before we do that, a question for you. Why did the greeting card come after your birthday?
Postulate? Post? Too late?
Postulate. Oh, that was a bad one. We'll run with it.
You have to read it slow.
Yeah,
it'll take you some time to get it.
Yeah, that's fine.
It's good.
Put that down in your whisk if you're not quite sure what happened. All right, warm up. So you're going to take a look at the warm up, run through these 2 questions, pause the video, and when you're all set and ready, go ahead and start it up again, and we'll check our answers. All right, so taking a look at the first one, measure of angle C. To figure out the measure of angle C, we notice that we have an X there. The problem is what am I supposed to do with it? I don't have angle A measure. The only other place in which I have an X is right here. And we do notice that this angle should be 90 degrees because it's perpendicular. The segment B, whatever, and AC are perpendicular. Therefore, this should be 90 degrees. Set it equal to 90. Solve, you get X is 20. Once you get the 20, you throw it back in there, and that's how you get your 31. For Y, we know that AB and BC are congruent because AB and BC are indeed congruent there, duh. We set them equal to each other, and we added the 7, and you ended up getting 19 for the Y. So let's go ahead and talk about how you can prove triangles to be congruent. So there are 3 different ways in which we can prove triangles are congruent. The first one we're going to talk about is something called SSS. It's representing what we consider to be side, side, side. So 2 triangles can be congruent if they are congruent with side, side, side. They could also be congruent by SAS, which represents side, angle, side. Or, for the last one, 2 triangles can be congruent by ASA, which is angle, side, angle. We're going to go through each one of these to make sure that you understand what's going on with them. So for the side, side, side SSS congruency, we can prove that 2 triangles are indeed congruent by just proving that their sides, all 3 pairs of them, are congruent between the 2 triangles. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then we know that the 2 triangles are congruent. The next one was side, angle, side, or SAS. Now the trick with this one is, if we're proving that 2 triangles are congruent by side, angle, side, notice where the A sits. It sits in between the 2 S's, meaning that if 2 sides of one triangle and the included angle, meaning it has to sit in between the 2 sides that are congruent. It has to actually be formed by those 2 congruent sides. If the 2 sides and its included angle are congruent to 2 sides and an included angle in the other triangle, then these 2 triangles are congruent. Hence, side, angle, side. The last way to prove triangles are congruent is by angle, side, angle, or ASA. Again, with this, pay attention to where the S sits. In this case, the S will sit between your 2 A's. So, if I'm working with 2 triangles, I've got 2 angles are going to be congruent in one triangle to 2 angles in the other. But the most important part of this is you're going to have the side included in between those 2 angles. So that's why it goes angle, side, angle. This side doesn't sit somewhere else. It's got to be angle, side, angle. So when we're proving triangles are congruent, there are a couple things that you're allowed to do. You are allowed to tick things on your own. You might be asking, what in the world is this? Google, tick the cartoon, maybe. And then you'll figure out why we are so old and you have no idea what we're talking about. So, 3 things that you can tick on your own with triangles. The first thing that you can tick on your own is, if you are working with 2 triangles and they share a side, of course that side is going to be congruent between the 2 triangles. So you are allowed to tick that off and use that as one of your pairs of congruent sides. Next, you can use angles that are shared between 2 triangles. If you notice, it almost looks like I've got 2 triangles that are overlapping each other here. And when they overlap, they share this top angle. So you are allowed to say that this top angle is congruent between the 2 triangles. So shared sides, shared angles, and the last thing you're allowed to tick on your own would be vertical angles. So if I'm using a diagram, And we'll try, oof, that's fine. If I've got two triangles, then vertical angles. If I've got a pair of vertical angles that sit between these two triangles, and of course we know vertical angles are congruent, I'm allowed to mark vertical angles as congruent. So 3 things you can tick: shared side, shared angles, or vertical angles. So, using SSS, SAS, and ASA, are these triangles congruent? I'll lead you through the first one, and maybe you can do the next 2. So in A, if I'm looking at this, what I like to think about is, what is it that I have? Well, I'm noticing that between these 2 diagrams, I have a pair of congruent angles and 2 pairs of congruent sides. So naturally, I'm thinking that we are going to have some sort of combination with 2 sides and an angle. And the only one that we've gone through so far that works would be a side angle side. Here's the problem with that. Is the angle that is congruent between these 2 triangles actually squeezed between my 2 congruent sides? Well, here's my congruent side and congruent side. Is the angle squeezed or made up by those 2 congruent sides? If you would say no, you are right. Therefore, these 2 triangles are not congruent because it is not side angle side. It is actually angle side side.
And we don't say that, you guys.
We don't say that at all.
No.
No. If you have no idea, write that out, and that is why we don't say it. So, we do not have congruent triangles here, and we'd say no for congruent triangles. Go ahead, try the next 2 on your own, and we'll see if we ended up getting the same answers. Alright, so looking at B, hopefully you ended up saying it was side, 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 and the reason why it's side, side, side is because not only do we have 2 pairs of congruent sides already, but you should have noticed that you are allowed to tick mark the shared side, and they share that middle side, so that's why it's side, side, side. In C, the answer would be these are congruent by side, angle, side, and the reason why they're congruent by side, angle, side is because of the vertical angles. So if you look at that, you notice they've got a pair of sides, congruent, a pair of angles, and then another pair of sides. So it's side, angle, side.
Alright, you guys, so this example asks you to show that the triangles are congruent for the given value of the variable. So they give you one triangle that has things labeled, like UT is y plus 3, angle T is 20y plus 12, and ST is 2y plus 3. And then they give you another triangle where you actually have the values. Well, let's take a look here. To show that the 2 triangles are congruent, we're either looking for side, 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 angle, side, or angle, side, angle. Given taking a look at what they give you, this triangle only gives you a side, an angle, and a side, right? So the only one that we could be testing for is side, angle, side. We don't have all 3 sides, and we don't have 2 angles. So let's check this out. If I know that y is 4, if I plug 4 in for y for these values, and it matches with our other triangle, the corresponding parts, we can tell that these 2 triangles are congruent by side, angle, side. So let's take a look. I know angle T would have to be congruent to angle W. So if angle T is 20y plus 12, and I plug in 4, I get 20 times 4 plus 12, which is 92. Is 92 equal to 92? It sure is. Therefore, we know that angle T and angle W are actually going to be congruent to each other. The next piece that I see is that ST would have to be congruent to VW. So let's take a look at ST here. ST is 2y plus 3. If I plug my 4 in, 2 times 4 plus 3, I get a value of 11. Well, does 11 equal 11? It sure does, which makes this side ST congruent to the side VW. Right? Last but not least, if you take a look at UT would have to be congruent to XW. So let's take a look at UT here. We have y plus 3. Well, if I plug this in, 4 plus 3 gives me 7. Does 7 equal 7? It sure does, making it UT congruent to XW. Now, if you take a look at your triangle, I have a side, an angle, and a side that's congruent to a side, an angle, and a side. Therefore, these 2 triangles, so triangle STU, would have to be congruent to triangle VWX by side angle side. Last but not least, we're going to have you complete a proof before we finish up. So they tell you that C is the midpoint of BD. You should know automatically that a midpoint cuts a segment into two congruent pieces, so I would mark those congruent pieces. It also tells you AB is congruent to ED, and then it tells you that AC is congruent to EC, and they want you to prove that these two triangles are congruent. Well, right away, just doing that labeling, you should see 3 sides congruent to 3 sides, so we should end up with side, side, side. So now that we've talked through our proof, let's actually write it down. Step number 1 is given. Now, we can learn something from this first given, so let's write that down first. So step number 1, C is the midpoint of BD, and this is given. From this, if C is the midpoint, remember we said we have two congruent pieces. So from this, you should notice that BC would have to be congruent to DC. And the reason why, well, that's the definition of a midpoint. Now that I end up with two things congruent, I can go into my next step, go back up to my given. I've got AB congruent to ED, and I also have AC congruent to EC. This is given information. And I've gone through and I've already marked my picture. So now you can conclude that these two triangles, if you take a look, triangle ABC will have to be congruent to triangle EDC, and your reasoning, you guys, we marked our picture, would have to be side, side, side. It's as easy as that. Regular proof we've done before, the only thing we're adding is this extra part to prove that the triangles are congruent. Make sure that if you have questions on this, you write it down in your whisk for tomorrow.